Okay, here we go with the solving equations. Now this should have been finished in class, but had it not, you can get some help here. So remember, the idea here is that we are going to be writing down the justifications for each of these, the reasons. So for these justifications, the main rules we are using, okay, are the addition, property of equality, which we abbreviate property of equality to PO, and usually I just do for subtraction sub-PO, multiplication multi-PO, div-PO, and dist-PO. Okay, those are the main five we use, as well as the additive identity of 0 and the multiplicative identity of 1. So which mult ID of 1 and add ID of 0. Okay, so these are the main ones that we're going to use. So let's take a look and get going on these. Okay, so first one, 5 equals r plus 13. So I'm going to subtract 13. I can do that from both sides because of the subtraction property of equality. Okay, that gives me 5 minus 13 is negative 8 equals r plus 13 minus 13 is 0. Then that additive identity property of 0 tells me we can just drop the 0 and get negative 8 equals r. Okay, so a lot of these first ones are just single steps, so you really only have the two justifications. Here we're going to add 9 to both sides, so I get negative 2 equals n plus 0, or minus 0, same thing. So that was the addition property of equality, followed by the additive identity of 0, which allows me to just drop the 0 and get negative 2 equals n. Okay, number 3, it's minus 19, so we're going to add 19 to both sides using the addition property of equality. Okay, negative 3 plus 19 gives us positive 16 equals r plus 0. Then that additive identity means we drop the 0 and get 16 equals r. Okay, so hopefully these are looking pretty simple because they're designed to be fairly simple, just getting us in that habit. So negative 9, we add 9 to both sides. So negative 10 plus 9 is negative 1 equals 0 plus k. So I use the addition property of equality. Then to drop the 0, the additive identity of 0 allows it to be negative 1 equals k. Number 5, we've got 5 minus r equals 1. So it's a positive 5, so I subtract 5. This one, don't add 5 because I won't get rid of it. So using the subtraction property of equality, gives me 0 minus r equals 1. Then I use the additive identity, but that negative stays with the r. Okay? So we can, it's like a negative 1, so I can divide by negative 1 on both sides using the division property of equality. Okay? Then that would give me 1r equals negative 1. So then I'd have to use that multiplicative identity of 1 to have a r equals negative 1. Okay, so that one did go off a little bit, was more steps, just because you had that negative r. Okay, now number 6, we've got a negative 4, so we add 4 to both sides using the addition property of equality, giving us 0 plus n equals positive 1. Then we can drop the 0 using the additive identity of 0, and we're good on that one. Okay, next up, number 7. So we've got n plus a negative 19, plus a negative is the same as minus. So we're going to add 19 to both sides. Negative 7 plus 19 is positive 12 equals n plus 0. Drop the 0 and we get n equals 12. So again, we use the addition property of equality and the additive identity of 0. Okay, should see a lot of similarities here. between these first ones. So 22.5 equals k minus negative 8.7. Minus and negative is really like plus. So we're subtracting 8.7 from both sides, giving us k plus 0 on the right side. And then 22.5 minus 8.7 gives us 13.8. And that was a subtraction property of equality. Okay. Then we can drop the 0 with the additive identity. We get 13.8 equals k. Alright, number 9. So I've got 19.4 minus r equals 2.3. So that's going to be similar to this one, isn't it? That was a bit longer. Okay, so let me do these other ones and then we'll jump back to that one. Okay, number 10. We can add 4/3 to both sides. Okay, now if we're not good with fractions and adding, okay, we can definitely use a calculator. We can do this because of the addition property of equality. But I need to get 3 to be 15, so I times this one by 5, giving me negative 2 over 15 plus 20 over 15, which would be negative 2 plus 20 is 18 over 15. So I have 18 over 15, which I probably should reduce that, huh? So divide them both by 3, and I would get 6 over 5, or 1 1/5, or 1.2. Either one of those works. So 6 over 5 equals x plus 0. That would be our, then using our additive identity, property of 0, we drop the 0, giving us our answer right there. So clear some space here. Okay. Now looking at 11, now we've got multiplication here. So to undo the multiplication, I divide by negative 12 on both sides using the division property of equality. Okay, that becomes 1r equals 168 divided by negative 12, which I don't know that one offhand. So I'm grabbing a calculator, which would be negative 14. Okay, then to drop the 1r, we use that multiplicative identity of 1, and we get r equals negative 14. Okay, 12 we do in similar manner. We divide by a negative 11, giving us 1n equals negative 176 divided by a negative 11, so a positive 16. Then we drop the 1, and we get n equals 16. So again, we use the division property of equality, and we can use that multiplicative identity to get rid of it. Okay, so 13 and 14. Now we've got n divided by 3. So I want to times both sides by 3 using the multiplication property of equality. 3 over 3, or 3 times 3 divided by 3 will give me 1n equals negative 19 times 3, which is negative 57. Then using that multiplicative identity, we drop the 1, and we get negative 57 equals n. For 14, same idea, it's dividing by 7, so I times by 7. 7 over 7 gives me 1, so 1p equals negative 140. So again, use the multiplication property of equality, and then we drop the 1 using that multiplicative identity property of 1. Okay, so we still need to take a look at number 9. So give myself some more space here, because I know I'm going to need more space. Okay, so I subtract 19.4 from both sides using the subtraction property of equality. Gives me 0 minus r equals 2.3 minus 19.4, which is negative 17.1. Then using the additive identity, I drop the 0, giving me negative r equals negative 17.1. That's really like negative 1, so I divide by negative 1, giving me a positive 1r and a positive 17.1 using the division property of equality. I could have also multiplied by negative 1 on both sides and got the same thing. Then using that multiplicative identity, we drop it to r equals 17.1. Okay, so there's the front page. So, quite a bit of stuff going on here, but we treat it exactly the same. Okay, so x divided by 8, we times both sides by 8, giving me 1x equals negative 72, using the multiplication property of equality. Then we drop the 1, using that multiplicative identity. And remember, the whole reason we're doing all this, because it seems super repetitive, is just getting us to understand why we can do these steps that we can do when we're solving, okay, and understanding that. 16, we're going to divide by 19, giving us 0, because 0 divided by 19 is still 0, equals 1x. Get rid of that, and we got 0 equals x. So again, we use division property of equality. The multiplicative identity here gets rid of the 1. Okay, so moving on to the next. So we've got negative 5 times n, so we're going to divide by negative 5 using the division property of equality, which gives us 1n equals a positive, and I probably should know this number, but can't remember, so we'll jump onto my calculator. Positive 18. So then using that multiplicative identity property, we drop the 1, and we get n equals 18. And on question 18, it's n divided by 3, so we're going to times both sides by 3. Okay, that gives us 1n equals 5.49 times 3, and that's 16.47. So we used the multiplication property of equality. Then to drop the 1, we use the multiplicative identity, and we get n equals 16.47. Okay, then on this one we divide by 4.2 to separate it from k. So negative 67.62 divided by 4.2 gives us 16.1, and that equals 1k. Drop the 1, we get 16.1 equals k. And we used again division property of equality and that multiplicative identity of 1. Okay, now number 20 looks like it's really a lot more confusing, but you shouldn't worry about it too much. It's not too bad. So, first step, we can just times by 7 on both sides. That would give us 20 equals 8x, using the multiplication property of equality. Then we divide by 8, giving us 20 divided by 8 equals 1x. So we use the division property of equality. Okay, then to drop the 1 to get x equals, we would just use that multiplicative identity property. Now 20 over 8, we can reduce that to 10 over 4, which reduces further to 5 over 2. So you can write 5 halves or 2.5 or 2 1/2. Any of those work. Okay, now we're moving on to some that are a little bit more complex because they just have more steps to them. Okay, but everything else is the same. So I start off by subtracting 9. So 5 minus 9 would give me negative 5 equals 5a plus 0. So we use the subtraction property of equality. Then we use the additive identity to drop the 0. So negative 5 equals 5a. Divide by 5. We get negative 1 equals 1a. So we use division property of equality. And then we use that multiplicative identity to get negative 1 just equals a. Okay, then 22. We add 5 to both sides using the addition property of equality, giving us 7x plus 0 equals 77. use the additive identity. We get 7x equals 77. Divide by 7. We get 1x equals 11. Using the division property of equality. Then using that multiplicative identity, we get x equals 11. Okay, just moving on. Add 4 to both sides. On 23, giving us 0 plus v over 4 equals negative 3. Drop the 0. V over 4 equals negative 3 times by 4. We get 1v equals negative 12. Then we drop that to get v equals negative 12. Now, the rules again. First we use the addition property of equality, then the additive identity to drop the 0. Then we did the multiplication property of equality and the multiplicative identity to drop it. So now we're just chaining more than one together here. Okay, 24, we end up with adding 8. So 0 plus a over 4 equals negative 1. Using the addition property of equality. Then the additive identity drops the 0. So a over 4 equals negative 1 times by 4. We get 1a equals negative 4. So we get the multiplication property of equality. And then we drop the 1 using the multiplicative identity. We get a equals negative 4. Okay. Now, most of the time, honestly, when we're doing this, we could start to drop the identities because we know that we're going to do that. Okay. So I guess I could even kind of do this and say instead I'm going to kind of do 2 steps in one. So I'd subtract 9 from both sides. So 16 minus 9 would give us 7. Then I'm going to drop the 0 and just go to n over 2. So using the, not the addition, subtraction, subtraction property of equality and the additive identity, I can just skip to the next step. Then times by 2, and I get 14 equals n, and I used the multiplication property of equality and the multiplicative identity to drop the 1. So, if we really want to, we can do that as long as we understand how those work. So, subtract by 7, I get 3v equals negative 36. Again, using subtraction property of equality and the addition identity to drop the 0. Divide by 3, giving me v equals negative 12. Using the division property of equality and the multiplication identity. Okay. And finally, 27 and 28. I think I want to give myself a little more space for these ones, so I'm going to rewrite them. Okay, so, all right. So looking at 27, okay, 2 ways we can do this. One of them I'll do with distribution, the other one I'll just do them both with distribution since we haven't done any of those. So using the distribution property of equality, okay, I get 9 times negative 3, which is negative 27, plus 9 times n, which is 9n, equals 72. Then we add 27 with the addition property of equality. Then that additive identity will drop our 0. So that 0 gets dropped, so we just have 9n instead of 0 plus 9n. And 72 and 27 should give us 99. Then we divide by 9, giving me 11 equals 1n, which we drop to get 11 equals n, using both the division property of equality and the multiplicative identity of 1. and 11 equals n. Okay, last problem here. So again, we use the distributive property of equality. So I get 10 times v, which is 10v, minus 10 times 5, which is 50, still equals 30. We add 50 to both sides, so we get 80 equals 10v plus 0, but using the additive identity, we just drop the 0. And we also use the addition property of equality there. Then we divide by 10, giving us 1v equals 8. Use the division property of equality, then using that multiplicative identity, we just get rid of the 1. And there we go, guys.